In this lecture, we will understand what is offload location. In IoT systems, the devices like sensors and cameras cannot process heavy data. Therefore, we have to decide where should the processing happen. That place is called as offload location. So choosing the correct locations, it affects the application speed, cost, network bandwidth, scalability, and the sustainability. Now, there are four types of offload locations. The first is edge computing, second is fog computing, third is remote server, and last is cloud computing. So, edge computing is processing. In edge computing, the processing happens near the devices, that is on or near the edge devices. So, it is best for low latency applications and real-time decisions. So next is the fog computing, where the processing happens on local intermediate nodes, for example, gateways and local servers. This type of computing, it is best for local analytics, reduced bandwidth usage and improved response time. The third is remote server, where the processing happens on a server in a remote data center, that is on premise or co-located. And this type of offload location, it is best for more compute power and the centralized control. And last is the cloud computing, where the processing happens in the cloud over the internet, and it is best for massive scalability, high availability, global access, and large data storage. Now we will look at these offload locations one by one. First is the edge computing. So it is nothing but where the processing happens near the device. So here the processing happens on the IoT device, that is the processing is done directly inside the device like a smartwatch or a sensor. Okay, and this avoids sending the data outside, making it faster and more efficient. And also sometimes the processing happens in a nearby device like a gateway or a local server. This still keeps data close and reduces the communication delay. Now, the goal of this type of offload location is to reduce the delay, that is the data is processed immediately without waiting for cloud communication. This is important for time sensitive applications. Second is to reduce the internet usage, that is only the important data is sent to the cloud. Not all raw data is sent to the cloud, only the important data is sent to the cloud, and this will save the bandwidth and it reduces the cost. Next is the quick decision making, where because the processing is local, the decisions are taken instantly, and it is useful in emergencies or real-time systems. So one real-time example for this is the smart healthcare wearable, where a smartwatch monitors the heart rate, and a smartwatch continuously it monitors the heart rate of a person instead of sending all the data to the cloud, and the device, it analyzes heart rate and detects the unusual patterns instantly, and here there is no need to wait for external processing, and only critical alerts are sent to the doctors or the servers, and this reduces the unnecessary data transfer. So the result is what? The result is faster response, that is immediate processing helps in quick action during the emergencies, and this can save the lives in critical situations. And second is less internet usage, because only important data is sent, network usage is minimized, and this also reduces the operational cost. And one more example is the smart traffic signal, where the camera detects the vehicles locally and the traffic light changes instantly. Here there is no need to wait for the cloud. Now, advantages of edge computing are it has very low latency, that is processing happens near the source, therefore the delay is almost zero, and it is ideal for real-time applications. Second is a real-time decision, where instant data analysis allows the immediate actions, and it is useful in healthcare security and automation. Next is the reduced bandwidth usage, because less data is sent over the internet. This improves the network efficiency. Now, there are some limitations also for this, that is it has limited storage. That is the IoT devices here which are used have very small memory, therefore they cannot store large data, and this limits the long-term data handling. Second is the limited processing power. Because the devices are not as powerful as the cloud servers, the complex tasks may not be handled efficiently here. Okay, so one example you can give for this as a like a student solves easy problems themselves instead of asking the teacher every time. That is one real-time example or the classroom analogy for the edge computing. Second is the fog computing, where the processing happens between the edge and the cloud. So here the processing happens at intermediate levels, that is the routers, gateways, or the local servers. That is, the processing is done between the edge device and the cloud. So the devices send the data to nearby systems like gateways or the routers for quick analysis. Now here the goal is to reduce the internet traffic, that is only important or processed data is sent to the cloud, and this will reduce the unnecessary data transfer over the internet. And second is it is faster than the cloud. Because processing is done closer than the cloud, the response time is quicker and it avoids the long distance communication delays. And third is it supports mobility, that is the fog computing can handle moving devices like vehicles or mobile users. Therefore it provides a continuous service even when the location changes. Okay, one real-time example is the smart factory. Here you can see the smart factory. So here the machines in a factory, these will produce like a large amount of data continuously, and then it will send all the data to the cloud, which would be slow and inefficient. Okay, so the fog node the fog node, that is a factory gateway, it will collect the machine data. That is, the fog node gathers the data from the different machines in the real time, and it acts like a local server. Okay, and it detects the faults locally, and it quickly identifies issues or failures in the machines, and it will help prevent major breakdowns. And it also sends a summary to the cloud, that is only important results or summaries are sent to the cloud, which saves the bandwidth and the storage. Then workers will get the instant alerts here. Okay, here these will the workers will get instant alerts, that is, if there is any problem which is detected, alerts are immediately sent to the workers, and this will ensure quick action and the safety. Another example is the smart transportation here. So here the vehicles will send the data to the roadside fog server. Then the traffic patterns are analyzed locally here. Advantages are it has low latency than the cloud, that is processing is closer than the cloud, therefore the delay is less, and it is good for near real-time applications. And second is it is good for moving devices, that is, it supports the mobile systems like cars and drones, and it maintains connectivity and performance. Third is the effective bandwidth usage, where only filter data is sent to the cloud, and this reduces the network load. Then the limitations are it requires the local infrastructure, that is, it needs the installation of gateways, routers, or the local servers, and this will increase the setup and the maintenance cost. So here you can understand, like here there will be a class representative who will collect the assignments and give summary to the teacher. This fog computing, it acts like that. Third is the remote server, where the processing happens at a dedicated powerful server. Therefore here the processing happens on a powerful external server here, that is, the data is processed on a high performance server with better CPU and storage, and this server handles heavy tasks than the IoT devices, which the IoT devices cannot manage. Second is the that is, it is not cloud based, that is, the server is not a part of a public cloud services like AWS or the Azure. It is dedicated system which is used only by a specific organization, and it is usually owned by an organization here, that is, the organization will install and manage its own server, and this will give full control over the data and its operations. Now, one real-time example for this is university CCTV monitoring. where the university will have its own data center server, where all the video data is stored and processed in a central server inside the campus, and there is no need to depend on external cloud services. And all the campus cameras will send video to the central server. Okay, here where the CCTV cameras continuously stream the video to the server, and the server analyzes and stores the recordings. Okay, and another and here it is controlled locally also, that is the security staff. Okay, the security staff here can monitor and manage everything within the campus, and this will improve the privacy and the quick access. One more example is the hospital example, where hospital has the internal server. Okay, internal server for monitoring the patients. Now, advantages are high processing power, where these servers are strong enough to handle large data and complex tasks, and it is better than the edge devices in the performance. And second is a controlled environment, where the organizations has full control over the hardware, software, and data, and there is no dependency on third-party services. Next is the secure local management, where the data stays within the organization, which improves the privacy and the security, and it is useful for sensitive information like health or surveillance data. Next is the limitations. First is expensive maintenance, that is the setting up and maintaining servers requires money and technical staff, and it includes hardware, electricity, and updates. Then second is the limited scalability, that is if data increases, then upgrading the server is difficult and costly. Therefore, it is not as flexible as the cloud systems. So here you can think it as a college which has one big computer lab, and it is used for heavy simulations. Next is the cloud computing, where the processing happens remotely. Okay, that is here the processing happens on internet based remote servers, where the data is processed on the servers located far away and accessed through the internet. So the devices will send the data online, and the results are returned after the processing. Now, some example are the AWS, that is the Amazon Web Services, which is a popular cloud platform that provides storage, computing, and AI services, and which is used by many companies for large scale applications. Then second is the Azure, that is a Microsoft Azure, which offers the cloud service for the data storage, analytics, and application development, and it is widely used in industries and the enterprises. Then next is the cloud, that is a Google Cloud, which provides the powerful tools for big data, machine learning, and the global applications, and it is known for strong AI and data analytic capabilities. Now, one real-time example for this is a smart agriculture, where thousands of sensors will collect the soil, moisture, temperature, weather. That is, there will be many sensors in thousands which collect the data, and this data is sent to the cloud for storage and processing. And here this will store the that is the cloud will store the big data, where the cloud it can store very huge amount of agriculture data safely, and there is no limitation like local devices, and it will runs the analytics, where the advanced tools analyze patterns in the data, and the farmers will get useful insights for better decisions. And third is the it will predict the crop yield, that is using the artificial intelligence and the historical data. The system predicts future crop production, and it will help in planning and improving the productivity. So here one more example is the healthcare example, where the patient data from many hospitals, it is stored into the cloud, and then AI analytics, that is the AI will analyze the disease patterns globally. And advantages are unlimited scalability, that is cloud can easily handle increasing data and the users, and the resources can be expanded anytime. Second is a global access, where the data and the services are accessible from anywhere via the internet, and it will support remote work and the collaboration. And third is the high processing capability, where the cloud servers are very powerful and handle complex tasks, and it is suitable for AI, big data and the analytics. And some limitations are the higher latency. Because the data travels longer distances, the response time can be slower, and it is not ideal for real-time applications. Second is the internet dependency. So here you can think like cloud services require a stable internet, and if the internet fails, the access to the data is affected. That is the internet dependency. So like the students will upload the assignments to online Google Classroom. Okay, this is one example for the cloud computing. So here this is the comparison of the offload location types. So here the parameters which we have taken are the processing place, speed, cost, and where it is used, like the best use of this. So here the type of location is the edge. It is used in nearby devices, and the speed will be very fast. Cost is low. It is used in real-time decisions. Then here fog. Here we use the gateway or the local server for processing. That is, the processing place will be the gateway or the local server, and it is fast. The cost is medium, and it is used in smart cities. Then next is the remote server. The processing place here is the organization server. The speed is medium, cost is very high, and the best use, like where it can be used, is at the institution. Then next is the cloud. So here the processing place for this is the internet servers. The speed is slowest of all the four here, and the cost is very high, and here you have to pay as you use it, like your internet. Then best use here is the where it can be used is the big data analytics. Okay, so here this is a visual from the device to the cloud. You will be having the IoT devices. So if you are using the edge type, then it is nearer to the device. If you are using the fog, then here the processing place is the gateway or the local server. If you are using a remote server, then the place is organization server, and the last is the internet server. So here edge is the closest, and it is fastest and the low cost, whereas the cloud is the farthest from the devices, and it is slowest but most scalable. So the distance from the device, as the distance from the device increases, you can see here, as the distance from the device increases, the speed decreases. The cost also increases from the edge to the cloud, and so we have to choose the type of offload location depending upon the application needs. So this is about the offload location. Thank you.